retesting of failing units is very common in the electronics industry, but most companies have little visibility into how frequently this is happening or how it is affecting the performance. There's not only the quality aspect that is concerning with this, but also the time inefficiencies that this brings. As a simplified example here, if you run a production line with 85% first pass yield in one test process, approximate connection execution time of 3 minutes and 35 USD unit cost, then you probably spend about 180 hours simply retesting products, or 6.3% of your unit costs come from retesting from this factory time alone. And it's not only that, but it also steals the potential bandwidth of your test system. So 30% of the time taken in test goes to retesting products. Now, if you simply increase this first pass yield to 90%, then you will, number one, reduce the unit cost by more than 2%, but you would also free up considerable bandwidth in your tests. So rather than buying new test equipment, you can actually get more out of the existing test systems. So the way that we approach this is in WATS to see how frequently are your products being retested is in this periodic yield report that you can access over here under the yield reports. And this report will break down volume and yield metrics per time period. So we've selected month here. We're going to get the data per month. And if I expand this one, first it will just show me the different part numbers that has been produced within this period. Right now I am only looking at one specific part number, so it's only going to list one. But if I scroll all the way down here, I will get a past in run chart. And what this tells me is for all the units, all these 207 units, that has passed in this period, that did not pass in the first attempt, when were they tested good? So 24 of those were tested good in the second attempt. 10 of those were tested good in the third attempt. 2 of them in the fourth attempt. And I can click directly on this graph to see what is the unit history or serial number history for these. So I'll just simplify this a little bit and only look at one of them. Here. So this serial number was tested, failed 3 times, then went to module production repair and was tested good afterwards. And after that it's been tested as a subunit in this other serial number, OLC 130, that is a master unit. It's a little bit easier to see down here. So other than the time taken retesting here, it's no real concern. But if I go back on this chart and look to the right, you can see you have one unit tested 18 times and one tested 19 times even before passing. If I click on this one to see what is going on here, then I'll get the serial number history down here. It's been tested in PCBA test, failed a bunch of times over the span of 3 days. It's 23rd, once on September 24th, and then the rest on September 25th. Here, it eventually passed, was then tested on a different, it was then tested in a different test process, final function test, but as a subunit. So it's been built into this final unit that is OLC 130. The one we're looking at here is OLC 130P. That's the power board in a final product. And then shortly afterwards, it's been tested in an RMA test, so it's something that has been returned, and it's failed in there. I can also see here that the station names here are different. So all of these are OLC FT01 station, but the last one here is FT02. So it's been tested on a different test station in the attempt where it passed. If I want to understand why specifically did this unit fail, then I can drill down into the serial number and look at test step yield and analysis. And so I can see here there's actually two different software sequencers that has been used. It's version 1.12 18 times and ones with 1.11 as well. Scroll down to the failure Pareto, and it's only one failure. So all of the 18 fail attempts, they came from the same step, charge rate C41. You can click on this to open up the measurement view. And here you can see, so all of these failing measurements are above the upper test limit, the red line over here. But for the last attempt, the one where it actually passed, the test limit is higher. And that was the one that was tested on a different test station. And also using a different software version, so an older software version. So that is also something that could be easily avoided if you were using the software distribution module in WATS. And this module lets you automatically distribute the latest software version and firmware versions for the units themselves out to all the test stations that you have.